I have this data 13579, and then we have this assignment. We have this assignment. So I want to check whether A is less than B. We have this print, and then else, and then we have this. So what is the primitive operation? The assignment of an array, we have, this is 1. And then when we do this operation, we have 2. Because the first is to assign a variable into one of the array. So one of the array is L1 index 0. So this is one operation, and this is one operation. So there are 2 operations. What about this? B equals to L1 index 4. This is also 2 operations. So if we have this if function, this is one operation, this is one operation, this is one operation, and this is one operation. Okay, we should have also the line 7. Sorry, I have forgotten. So the best case, in the best case, we have 8 operation, and the worst case we have 8 operation. We don't have any n operation. We don't have any loop. So this algorithm is approximately functional. Now I have another code like this. A is an assignment of an array or a list. And then prop, I would like to start from 1. So for I in A. So we are going to check for every element in it. So we have prop equals to prop multiplied by I. It means this is one operation. This is one operation. For this one, we will multiply, or we will check for every element. If there are 5 elements, then we will do for 5 times. If we have 10 elements, then we will do for 10 times. So because this is an operation, it depends on the number of it. And we will do this operation, which is the assignment 1 and multiplication 2. So there are 2 and operations. The last one is only one operation. So in total, if we calculate this one, 1 plus 1 plus n plus 2n plus 1, then the best case and the worst case will be 3n plus 2. So the algorithm is linear n. Because this one we have n, so we will learn later that we will just use the higher order. Now, let's look at another example. Suppose we have data in the list such that A is 1, 2, 7, 5, 4, 8, 3, and 6. So you want to find the maximum value among the elements. Okay, we want to find the maximum value. So if we look at this data, I think it is easy. Okay, this is the maximum value. But I want to use this function, which is find max A. Find max A means I want to check from the list A, and then what is the maximum from this A. Now, there is one algorithm like this one. What is the algorithm error? Okay, so we will check one by one. So by inspecting the pseudocode, we can determine the maximum number of primitive operations executed by an algorithm as a function of the input size. So I have this input size, the data, is a list, and then I would like to check for every of the primitive operation, and yeah, we can calculate like what we did before. So this is the examples that I show you before. If we just evaluate the expression, it is primitive operation. If we just assign a value, it is also a primitive operation. If we just indexing into an array, it is also a primitive operation. If we call a method, it is also a primitive operation. And if we return a method, this is also primitive operation. So you can see, yeah, this is a method and this is a parameter. This is return, is also one primitive operation. So if you look at this now, we can see line 1. In line 1, we call a method. Okay, so we have the method name. So call a method is 1. And then we have the assignment of value to a variable. So we put this data into this method. So it means one operation and one operation. Line 3, okay, line 2 we do not consider because it is not method. In the line 3, we have the assignment. This is one operation, and this is also another operation. So we have two operations. Line 4, we have a loop. Okay. So we want to assign a loop. Assigning to a variable, of course, we have to val. Val is a variable which is from the data. And then whenever we call this data, we have the assignment, which is one operation, and we have the index of the array is also one operation. Okay. So assigning a value to variable, it means indexing into an array. This is indexing into an array, and then repeating until n byte. So we will repeat until n bytes or to n. This one, well, higher than biggest. So the biggest is a variable here. So I want to check only this statement. So this statement means, well, actually this is a value from an array, or it is a value from one list from this data, and then we want to compare with the figures. Okay, so we have this one as 1, and this one also one operation. It means we are going to use two operations, multiply by. Now number 6 means, yeah, if the condition is true, if the condition is true, then we will do this one. If the condition is not true, then repeating until n if the condition is true. So if there is no true condition, you can say it is just true. If there are some values that we need to check, then we will go until n number. So this one is the minimum, and this one will be the maximum. And the last one we can just return from the method. Okay, so we have this one. So 2 and then 2 operation to n to n 0 until n. In this case, I can say that the best case, okay, the best case is 4n plus 5. Why? Because there might be 0 operation. So if we have 0 operation, then we will not do until n time. We just keep this line. But if we do this operation, the worst case is n time. So we have 5n plus 5. Then the running time estimation, the FindMax algorithm will do 5n plus 5 primitive operations in the worst case and 4n plus 5 in the best case. So let's define A. A means time taken by the fastest operation, and then B, time taken by the slowest primitive operation. So in the mathematical, we would like to say that the Tn is the worst case of the maximum function. So we can say that this is the best case, which is A multiplied by 4n plus 5. And this is the time, the worst case time that we will take. And yeah, this is the higher or the highest function. So this is the function for the worst case, and this is the function for the best case. Hence, the running time Tn is bounded by two linear functions. So this is linear and this is linear. Therefore, we can say that, okay, this is also linear. Well, the time will be n or linear function. Then how we can see this grouping rate? In the grouping rate, changing the hardware of software environment, it will affect the n by a constant factor. But it does not alter the growth rate of Tn. So if you use laptop, if you use desktop, or if you use your gadget, pad, or you use your smartphone, it will just affect the constant factor, but it will not affect distance. So the linear growth rate of the running time Tn is an intrinsic property of finding FindMax. So maybe this will give you more obvious example. Now I'm going to check the data one. Okay. So the data one, I have only 1, 2, 3, 4, 5, 6, 7, 8. Okay. I have 8 data. And then the data two, I will have the second data is the list of salary from the population in Seoul. So let's say in Seoul there are 8 million people. Then it means we have this data for 8 million people. Okay. Now, I want to check if my algorithm previously is n. So what is n? So the running time is n, so it is linear. Then the operation when I have only 8 data is like 8 operation. But if I have the data is 8 million, then it will run 8 million times. because it means I would like to check one by one. Like this. Now, if you can make your algorithm faster, it means you can find a way to make it as a log n. If it is log n, what does it mean? Log 8. You still remember what is log 8? In the mathematics, yeah, we use this log. Okay, in this case, we use the log base 2. Use log base 2. Log base 2, and then we put the number 8. It means when we have 8 data, we will run approximately 3 operations. If we have 64 data, we will approximately run for 6 operations. So it means this is faster than the n. What about if we have our algorithm is n log n? Because this is a more operation happens. We will multiply it with log 8. So we will multiply it with 3. So if the data is higher, of course, it is higher. What about n power of 2? Yeah, we have this 8 data, and then we want to, so there will be 64 operations if we have n power. If we have n power of 3, so we have 8 multiplied by 8 by 8. If you have this exponential, this is the highest one. So in order to run 8 million data, you can see it is 2 power of 8 million. So it is very easy. That's why whenever we do this kind of algorithm, we want to find the minimum. Okay. Find the minimum runtime. If it is possible, you can find log n. If it isn't possible, you can just find n. If it is still not possible, try to reduce it to n log n. So there are 2 algorithms in this case. Yeah, in the okay, I will give you the template proposal for you to write for the team project. Okay. So this is one of the possible result when you do the team project. If you are going to compare 2 algorithms, let's say we have the first algorithm is insertion sort and the second algorithm is merge sort. So let's say I'm using the algorithm analysis and the complexity of the insertion sort is n power of 2 divided by 4. And then for the merge sort, the complexity is 2n log n. So after you do with this algorithm analysis, so this is the algorithm analysis based on the pseudocode. After you do this analysis with pseudocode, you need to do experiment. The experiment, I think you already learned last week, we can run the code and then make different numbers. For example, yeah, I want to make a random number until 1 million. Then if I have 1 million data, and if I use the insert method, it takes 70 hours. And if I use the merge sort, it takes 40 seconds. So which one do you prefer to use this algorithm? Are you going to use insertion sort or are you going to use merge sort? Of course, you're going to use the merge sort because it takes 40 seconds to sort 1 million items. If you use insertion sort, then you need to wait very long. And if you run your experiment, you can do the plotting like this. Okay, you can plot. Okay, when the number of element is high, then this is the insertion sort, and this is the merge sort. Okay, then you can see that okay, the two algorithms shows that the merge sort is better for the experimental. And also from the comparison or from the complexity analysis based on the algorithm pseudocode, it shows better than the insertion sort. Okay, so this will be your final team project result. So the growth rate is not affected by constant factors or lower order terms. Okay, what does it mean? When you have the quadratic, this is the quadratic. So it depends on the constant where you start this quadratic. If you use your tablet, maybe you will start from this one. Maybe when you run with your smartphone, the constant factor will start from this one. But the running time will be still have the same function. And then we can also see at the lower order. So if you look at this one, 10 power of 2, it means this is 100 multiplied by n plus 10 power of 5. So we call this is a linear function because we have n times, and then the lower order term, which is this one, it will not affect too much. The second one, 10 power of 5. So it means 10,000 multiplied by n power of 2 plus 10 power of 8 n. So this quadratic function. Why? We will disregard this one. We just want to find the highest order. So the lower order terms is not affect, does not affect the result. That's what we call as the constant factors and the lower term. And when we do with the time complexity, we will have also the space complexity. What does it mean by space complexity? So space complexity, it estimates the memory requirement for the execution. We can say that this is the required space of the input. So how many space you need to put for doing the algorithm. And the required space for the intermediate problem. And the temporary data in the data structure, and also the required space of the. So let's see if I have this algorithm. Well, so this algorithm is a method. So we have the square numbers with an array, and then for number in n, so for number in n, we want to check the square numbers, append number multiplied by number. So it means we want to make the square of the number, and then we want to put it into the list in the square number. Then we will return the square numbers if I put this input 2, 3, 5, 8. So if I print this one, What is the space complexity? So the space complexity, the output is 4, 9, 25, and it requires memory allocation for the number of items in the input. So if the input is 4, so I will also get the output is 4. So say the number of elements in the input n, then the space requires increase with the input size. So if we have this is n, then we will need also to have the output as n. So the space complexity is n. Okay, that's the meaning by the space complexity. So we can just say that the number of data that we want to check, or the number of data that will be saved in the memory. Okay, I think due to the time limitation, I will stop this. We will learn more about the speak O rotation on Wednesday. Thank you very much for attending the course, and see you on Wednesday. Sure,